Our product managers here at Bentley focusing on structural software. We've been involved with the RAM products for a number of years, and those are the products we'll be focusing on today, specifically RAM Elements and RAM Structural System. We'll also be focusing on a very specific type of building for today's Tech Talk, one that's a common type of construction with schools, K through 12 possibly. It's one that's about 1 to 3 stories in height, has steel-framed roofs with a metal deck. It could have floor levels framed with composite steel beams, and it has masonry walls serving as bearing walls and as lateral load-resisting elements. And that's really the focus of the discussion here today, specifically properly accounting for the lateral load path and designing the masonry walls properly for the lateral actions. Okay. We chose to talk about this type of structure for a couple different reasons. First, it's a fairly common type of system, obviously, but maybe one that doesn't get addressed quite as much as a pure steel or a pure concrete framed building. Also because there are a few nuances in the settings, both in setting up the model properly and in getting your analysis settings correct to make sure you're doing things properly. Okay, and the third reason that we wanted to talk about it is that the ideal workflow for this building is one that involves 2 different products, so RAM Structural System and RAM Elements, whereas we use the strengths of each of these programs together, and we want to cover the best practices here. Okay, so what we're discussing here specifically today is a process where you start in RAM Structural System, model the complete building, then take advantage of the steel floor design, the analysis of the structure for systematic lateral loads, then design the frames in RAM frame also, because you could also have braced frames or moment frames in this type of system. Then we move to RAM Elements, where we assess the walls for the out-of-plane loads and design the structural masonry. Okay, like Natalie said, this is a very interactive session. We'll stop and answer your questions as we go here. Feel free to ask them at any time. I'm going to get us started with structural system, and then Francisco will be talking about RAM Elements. Okay, so we'll start with a very basic description of the lateral load path here. We have a steel-framed roof using metal deck supported by steel beams or steel joists. Masonry walls serve as the load-bearing and lateral load-resisting elements. The roof and any floor levels framing to the wall act as brace points which support the wall out of plane. So the wind hits the face of the wall and the wall spans vertically, effectively as a one-way slab to deliver the lateral loads to the diaphragms. Okay, so from there, the lateral load is distributed through the diaphragm to the walls running parallel to the load direction. The seismic load path is similar, except that it's only the inertial force of the wall itself that needs to be developed from the wall into the diaphragm. Okay. A characteristic of this type of building is you're likely to have lots of openings and doorways in the walls to let light in from the outside, and that complicates the load path a little bit and is really where the analysis software can help you better understand what's going on. Okay, so the first specific topic we want to talk about on the structural system side of things are the out-of-plane forces themselves acting on the wall. Okay, when you generate wind loads or seismic loads in RAM frame, the resulting story forces are always applied directly to the diaphragm, like showed in the images here. So you can apply a lateral load, surface load rather, to a face of a building and structural system or to the face of a wall. So the result here is that the walls don't feel any out-of-plane forces between the stories. Okay. Having said this, and this is a key point here, the overall assessment of the building for drift and distribution of lateral loads to the walls in the in-plane direction, those acting as frames, is accurate in RAM structural system. It's just that we can't capture the loads applied along the vertical span of the wall. Okay, and this is part of the reason that we want to bring in elements into the workflow here. Okay, that leads us to the second point of discussion, which is accurately capturing the stiffness of the walls. You cannot model partially grouted masonry in RAM structural system. We can only model solid walls. So we need a way of modifying the stiffness of the walls so that the deflections and the load distribution to the frame walls is accurate. We can do this either by reducing the wall thickness and using an equivalent solid thickness from the masonry tables, or we can reduce the Young's modulus. These will both have effectively the same impact. Either way you go, you want to make sure that your wall thickness, your unit weight, and your Young's modulus are all calibrated correctly. So as an example, if you have an 8-inch normal weight CMU wall grouted at 32 inches on center for a 58 PSF wall weight, and you model the true block thickness, if you want to handle it that way, you want to reduce the unit weight of the masonry accordingly, and bring down the Young's modulus as well, okay, so that the gravity loads and the stiffness and the mass are all accurate. You can also model, the masonry walls as either type other or as concrete in structural system. If you model them as concrete, you do have a couple of additional factors that you can use, the crack factors in concrete. The choice between modeling a wall as type other or as concrete is really a matter of preference. A lot of people use type other simply because that way they know it is in fact a masonry wall as opposed to concrete. But the import intimate elements can handle it either way. Okay, a couple of words on diaphragm assumptions. There are two diaphragm types in RAM frame that are most pertinent for our situation here in this type of structure: pseudo-flexible and semi-rigid. The pseudo-flexible diaphragm type lets you specify explicitly what percentage of the story force you'd like to apply to each frame at a given level. Okay, so in this case, the story forces bypass the diaphragm altogether. This is a good option when the geometry is fairly uniform, and we can estimate the frame loads pretty accurately just using a tributary area approach. Okay, but if you need more precision, you can use the semi-rigid diaphragm type, which turns the diaphragm into shell elements so that the flexibility of the roof is considered. This is useful when you have mass concentrations at the roof, maybe due to a mechanical equipment, and also if the layout of the walls is pretty non-uniform. Okay, so as an example, in this layout we have here, if the wall on the far left, for instance, is a 12-inch solid grouted wall, and the wall on the far right is 8-inch partially grouted, the semi-rigid analysis will take care of all that proportioning for you, and will save a lot of time compared to a hand calculation. Okay, intermittent stories. Another situation you commonly face with a school in this type of structure is that there are several different wings in the facility, each having a different roof elevation. So you can have a classroom wing and then a gymnasium. So in a part of the building like the gymnasium, which could very well be the tallest, you might have several intermittent story levels in the RAM model that don't have much meaning for that specific part of the structure. And that's fine. Everything works for the most part as if it was a single story. Except there's one setting you want to double check here. RAM frame will try to associate the wall mass at these intermittent levels with any diaphragm that encloses them. Okay, and since there is no diaphragm at that area, it ends up ignoring the mass altogether. And the message at the top right of the slide there is what you'll see in RAM frame to alert you to that. So you want to go to the diaphragm masses dialog and set the combine to field so that these intermittent stories are combined to the true roof, the physical roof, the highest level there. Okay, so this way the full mass of the walls is associated with the roof like we expect. Okay, and lastly, a couple words on control joints. RAM structural system doesn't have a way of assigning a line release within a wall. If you want to model a wall joint, a joint in a wall system, you do need to place two walls side by side with a small gap between them. You also want to make sure that you connect the two walls with a beam element, since otherwise you will get a framing error when the gravity analysis runs. You'll get a warning that you don't have a closed framing loop there. You'll get that with a one-way deck, which is what we have here. And it's best to use the other material type when you're laying down the beam, because that way when you enter RAM steel, if you used a steel beam instead, RAM steel won't try to design that beam if you use a type other. Okay. Okay, checking the questions here. I think it's mostly related to audio, no technical ones as of yet. One more slide here. A couple closing thoughts on the RAM structural system side of things and getting your model and analysis set up appropriately to get it ready for the import into RAM elements. You'll go ahead and you'll do the analysis, you'll save the model, you'll close out a RAM structural system, and from there you'll launch RAM elements and then read in the RAM structural system file, the .rss file. That's how the interoperability between structural system and RAM elements works. Okay. All right, so at this point, we'll hand it over to Francisco to hear how this continues in RAM elements.
Thank you, Josh. Good morning, everyone. So Josh gave you the overall workflow on how the RAM structural system and RAM elements complement each other on the design of these type of structures. I'm going to talk a little bit more about what happens on the second half of the process, so when you are in RAM elements. And as I said, RAM elements complements the RAM structural system with respect to masonry design. Although the software is capable of designing structural components, just like a single shear wall or a full free model, for these type of structures that Josh mentioned, using them combined in a very efficient, well, it's a very efficient way to carry out this type of projects. Let's put it that way. After the finite element analysis, the engineer can design walls, columns, and or lintels with several options that include the codes being used. The first step after reading the full RAM structural system model, gravity and lateral systems, would be to generate load combinations based on a specific code and the load cases that came from the RAM structural system with automatic generation. The masonry walls defined in the RAM structural system come with a material that RAM elements does not recognize, so we must assign the appropriate masonry, either concrete units or clay, and thickness to the shells that represent the walls in the model. When you analyze the model, all load cases previously generated in the RAM structural system, plus the combinations generated in RAM elements are included. You have the option to disable whatever you don't want included in the run. After a successful analysis, you can start designing the masonry walls. RAM elements allows the design of walls one stack at a time. So as you can see in this image on your right, you'll see that the four shells or the four walls that form this four-story building were selected. So now we can send these to the masonry module. Once in the module, all analysis results come from the main screen, and you don't have to worry about them anymore. There's no manual transfer of loads that could be prone to error. In this module, you start defining all the properties of your wall, like the design code, the bond type, mortar type, grouting type. If the wall is to be designed as a bearing wall, a shear wall, or a combination of both, the elements you want included, like columns or lintels, and if it's a reinforced or an unreinforced wall, plus how many layers of rebar are to be included. All those options are handled on the left.
Excuse me, Francisco, we do have one question here while you're looking at the wall elevation there. It's do openings get imported into RAM elements?
Yes, they do.
From the RAM structural system?
Yes, they do.
Okay,
the answer
very good.
is yes.
There's a, okay, one other quick one, type other mass. This is more on the structural system side, addressing it while I can here. Type other mass, it does get included in the seismic self-weight. And the other one is, let's see, can you model a masonry infill panel between the steel framing to take lateral loads only? It looks like that might have been in context to the RAM structural system side of things.
I think so.
I'll think about that a little bit, and we'll answer maybe towards the end since it's a little more involved. Okay. Sorry to disturb you.
Perfect. Good questions there. So Your step number 9 would be, after specifying those masonry parameters that we discussed in the previous slide, right? The software will design the wall for you. There might be some cases where the software is not successful optimizing the wall. For example, when not even the maximum area of steel produced by the bars you specified satisfies the nominal moment. In this case, you would have to either increase the bar sizes to be used in the process or increase the wall thickness, maybe. However, you don't have to live with what the software designs for you. You're free to pick each and every one of the vertical and horizontal bars and specify your own sizes and dimensions. The software will then quickly verify your changes and let you know if they pass or fail the checks. Your bar layout can quickly be saved as DXF to start helping with the generation of the structural drawings. And you also have the option of comprehensive reports that allow you to understand clearly what the software is doing and are adequate to include in your design calculations. So that's all I had on the RAM elements side of things. If you guys want to ask any questions about this part or Josh's part or the overall workflow, you can clearly answer them now.
There are a couple here I'll go ahead and address, Francisco.
Okay.
Okay, so one that I see, I think I might have already answered in the presentation. What material should you model masonry walls with in structural system? You can use either the type other material or concrete. I think generally we've like in our demonstrations and things like that, we've modeled them as type other just so that you know the difference. You know that it is in fact a masonry wall and not a concrete wall, but I think either one can be imported into RAM elements. Next one I see, how refined of a mesh do you recommend using for the diaphragm and walls? Certainly pertinent because if we are going to in fact mesh the diaphragm as semi-rigid, then it's going to be a shell element analysis. So you know, I mean, I've dealt with a lot of concrete structures over the years, so, and those are shell elements in both the walls and slabs, multi-story, and I've found that starting with about a 4-foot mesh size, maximum node spacing size works pretty well. I don't necessarily have a quantitative basis for that, but I find it's a good mix between precision and speed. So I'll usually go ahead and set the mesh size to 4. And I'll mesh the structure. I won't analyze it, I'll mesh it, and then I'll take a look at how the mesh turned out. I'll look for any highly skewed elements or just, you know, any kind of, you know, distorted elements. And from there, I usually won't even reduce the mesh size. What I'll normally do is I'll increase the node density factor, I believe it's called, in RAM frame. It's defaulted to 1. And it's an integer value that can really go as high as you want, I think. And what that does is it places more nodes in areas where the mesh tends to get congested. So it places more soft nodes being the analytical nodes that it places in between physical objects, in the areas where there's high concentrations of hard nodes. In other words, hard nodes being, for instance, the corner of an opening or the end of a wall. And that's nice because it allows the mesh to still be pretty coarse in areas that are wide open, and there's not a whole lot of need for a lot of refinement with the mesh. So I'll start with about 4 feet. A long answer to the question, but I start with about 4 feet and handle it that way. And if that doesn't resolve it, then I'll consider decreasing the mesh size a little bit further. Okay, there is one more question I'll address right now, Francisco.
Okay, yeah, and then I'll go. I see a few on the masonry side. Yes. Okay. Please go ahead.
Can you use RAM shear wall designer for masonry? You know, we have the concrete wall design module on RAM structural system. Short answer, no. You might think that maybe you could use it for a solid grouted wall, but bear in mind that the shear wall designer in RAM implements ACI 318. So the phi factors, the minimum steel requirements, all that is purely ACI 318, which is really why we need to bring in RAM elements into this workflow here. Okay, Francisco.
Okay. I see one here that it's about second order analysis, and it says that the second order analysis is automatic in the software, or if the user has to manually inform the software to do so. In both products, it's just a checkbox, but you have the freedom to specify second order analysis or not in the software. There's another question that says, do you have to import the full model from the RAM structural system, or can you just import the lateral model when designing shear walls? It's your choice. If you have completely designed all the gravity system in the RAM structural system, then there's no need to bring the full model. You can just bring the lateral. Can you design the masonry shear walls with vertical cord reinforcing at each end of wall, or are you limited to intermittent? No. You are free to do so. The software allows you to create vertical strips. You define vertical strips, and you can set them to the ends to carry most of the loads, and then in the middle, the minimum will be set. How do you import from the RAM structural system to RAM elements? When you're done in the RAM structural system, you close the model there, and then in RAM elements, you go to, there's an option to import. And in the import category, there are two more options. One is the full model, and the other one is just the lateral model.
There's a couple questions here. I think we need some more clarification on the.
I see one related to diaphragms. I don't know if you responded to that one.
Yeah, there's a couple related to the diaphragms, and in particular the lumping of the mass to a diaphragm other than where it occurs. So basically, that if we could. Okay, could we do it? You know what, we can do it right here on this. This is actually a good slide here to do it with. So the masonry box that Francisco is showing here on this slide, you see kind of two, you see a joint, horizontal joints there on the bottom right side of the structure between the windows there. And if you can imagine that everything at that level, at that plane, is just open. Okay, there's no steel beams there. It's just an open gymnasium. And then at the roof there, we do, at the upper side of the building, we do have a roof. It's steel framed roof with metal deck. Okay. In RAM structural system, if we have two stories here, so the lower one being where that joint is and the upper one being the roof itself, when you enter into RAM frame, it's going to try to, in other words, it wants to treat it as two different stories. Okay. It sees though that there's no diaphragm laid out at the lower level. So what it says is, okay, I don't know what diaphragm to associate this mass with at this story, so I'm just going to ignore it. What you do instead is you tell RAM frame, okay, and there's a dialog specifically where this is done. I want to associate the mass at that level with the higher diaphragm. Okay, so that in the seismic calculations, that mass is accounted for, added to the mass that's already there. Okay. There was another question about, I believe it was essentially, when you do that, is the entire height of the wall going to be lumped to the roof level? And the answer there is no. RAM frame does that partitioning for you. And we can double check on that, but you should be seeing that it is in fact excluding the lower extents of this wall mass here. So that's done automatically for you. You might have some other situations where instead of the entire intermittent level, as I'm calling it here, instead of it all being open, there's just maybe a little mezzanine area. Okay, and that's another situation where you have some mass that you can either associate with that mezzanine at that level, or you can take it above to the roof level above. Okay.
All right. Good. I have a few here that I can address now. There's one about wall reinforcement if it represents both in-plane and out-of-plane? The answer is yes. RAM Elements designs masonry walls for in-plane and out-of-plane forces. So Josh mentioned that in the structural system you cannot apply an out-of-plane, but once you're in Elements, you can apply a pressure to any of your walls and have the module design it also for those out-of-plane forces. There's another one here about joints in the CMU wall. That's prior to calling the module to do your masonry design. In RAM Elements, there is a little tool that allows you to create what the tool, I believe it's called Insert a Gap or something similar, that will allow you to pick whatever wall you have in your model and insert a little gap there that would be your actual vertical joint before going into the module. So this is prior to the analysis and the design in the module. Another question, I'm sorry, why not use RAM Elements to apply lateral forces in lieu of using the structural system? Yes, you can do that. Certainly you can do that. The advantage of using the RAM structural system for lateral forces is the automatic load generation, right? In the structural system, you have very nice tools to allow for wind and seismic load generation that you don't quite have in RAM Elements. So that would be one of the advantages. But certainly you can also apply the lateral loads in the RAM structural system. Then there's one here, Josh, that if there's a table for the roof deck properties.
Okay, yeah, in RAM Modeler, when you specify a bare metal deck, you're just inputting basically the analytical properties. So the Young's modulus, the assumed diaphragm thickness. I don't believe it's read from a table directly as of now.
Okay.
Another one here, do you model differently if you have walls and steel frames in the same directions? And plus steel frames. Not really. The load distribution itself is taken care of automatically. The in a seismic application, you know, there would be the matter of what are your seismic parameters? What is your response modification factor? That kind of thing, which would weigh in. But there's really nothing special you need to do or different you need to do from the modeling standpoint. It should be set up pretty well to handle that geometry.
Okay, there's another question here about if the communication between the software is two-way. Currently, it's just one way. So you would go from the RAM structural system and finalize in RAM Elements. This is a workflow that we have very well defined and we have it well documented. There's no going back right now for the time being. Although we could use ISM maybe, right? Josh, what do you think?
Right, that would be one way to handle it, correct.
Okay. Then there's a question if the software will inform you if your shear wall design requires boundary elements, and the answer is yes. The software will let you know, and you can specify either columns or maybe walls in the other direction, like flanges, or the wall in case. And then you can also design assign hoops for those.
There's one that was asked earlier, Francisco, that I want to get back. We promised we'd get back to, and that's: can you model a masonry infill panel between the steel framing to take lateral loads only? And without seeing a sketch of the configuration there, I would say that if you have two types of members in structural system: those that resist only gravity loads and those that resist both gravity and lateral loads. We don't have an element that resists only lateral loads. But depending on how it's set up, whether there's any gravity framing sitting on the infill itself, it could be that just as a just the configuration of the model is such that you can get it to take only lateral load and no gravity. So strictly speaking, the answer is no, you can't do that, but it could be that it's possible with just the way that you choose to model it.
Okay, there's a follow-up to the question about importing just the lateral or the full model, and it says if the design combinations that include gravity loads do not get imported. No, they will. Even if you just specify the lateral system, it's just about the elements that are being imported, right? Beams, columns, and walls. The combinations will come. It doesn't matter.
Okay, another one here. What happens to wind load and if I'm blanking, Francisco, and you have in fact answered these, go ahead and stop me. But I'll long list of questions here. What happens to wind load generated when you have a small interior mezzanine? Will the wind force estimated at this intermittent level transfer to walls on other sides or be lost if we lump it to full level above the mezzanine? Okay. I have a feeling we might have a wiki written about this, or if it's not actually on our community site, we have some kind of technical documentation on this, because I think we've been asked this a number of times before. So unfortunately I'm going to defer, and when we follow up and answer these questions, we'll point everybody, all the attendees, to where these are answered in greater detail, and this is one that we'll include there.
Sounds good. There's another one here. If lintels include seismic provisions, the design of the lintel. Yes, you can include seismic provisions for the design of the lintels. Will there ever be a good wall module for RAM elements to design wood shear walls? Right now, it is not in our short-term development plans. If things change, we will let you know in our the communities or the website. But currently, we do not have a plan to develop a shear wall, a wood shear wall module. And I think those are it. Let me see if there's more to this.
Hey, is there, how about, there's one, should the intersecting L or T walls be modeled integrally or with a gap? Current project, since there's 6-inch gap and T walls rotated 90 degrees, seem to still act integrally and bear the majority of axial component of lateral loads. Okay. Yeah, it's pretty much all or nothing as that goes. There's no partial connection between adjacent walls, so and that's true of both types of loading, the gravity and the lateral. So yes, it's just a matter of engineering judgment if you actually want to place that physical gap there. But as of now, those are the options, to either physically model a small gap in there or connect them and get full continuity across the joint.
Okay, there's another one here that says, can we get your email addresses for further questions? Absolutely. Our email is very simple. It's our first name dot our last name at bentley.com. In my case, it's francisco.diego@bentley.com. And yeah, if you come up with some other questions that we didn't address today or that you think of later, feel free to email me, and I'm sure Josh is also available for questions.
Absolutely.
Here's another question about if RAM Elements allows you to model unreinforced walls using concrete masonry units, and the answer is yes. The wall could be reinforced or unreinforced, and yeah, you could use CMUs to model them.
Okay, Francisco, I'm not sure if you got this one or not, but for solid walls, there is not a good not a good method to model boundary elements with column reinforcing at the ends, and minimum reinforcing at center for concrete shear walls. Right. So right, RAM concrete is a little weak. Yeah, a little weak in that sense. I'll go ahead and answer this in the context of concrete. So what you're looking to do is place a column at the ends of the walls, and you really want to optimize the steel in those end columns and just leave a minimum amount of steel in the wall that connects them. RAM Elements is very good at this. There is a way to do it in structural system. RAM concrete rather, you would just model thicker walls at the ends rather than columns. That has the advantage in that there is no overlap. Like if you have a column there, then technically you have a little bit of overlap, duplicated stiffness. If you model them as 3 separate walls with the outer walls being thicker, you don't have that. But that being said, this is a little more friendly to do in RAM Elements.
Yes, and today's topic is masonry, right? But as you may know, the RAM Elements also has a concrete wall module. And if you're designing shear walls in that one, the software allows you to also specify boundary elements, whether as flange, perpendicular walls at the end, or as columns. I think those are all I see now.
Okay. A couple more coming in, it looks like.
Yeah,
some of these, and bear in mind that we're going to answer all of these, like we mentioned earlier, in detail. There'll be a landing site where you can see the questions that were asked and the responses.
Exactly.
And some of these, they get a little more detailed into the specifics. We'll defer to put a little more thought into them and answer them on the web page.
Correct.
Okay, so I think that
Yeah, that's it.
just about does it for Q&A.